In investigation 1, you first of all want to consider how you want to draw the iron, since the steel wool is mainly iron. Iron's an element, so you're going to be dealing with atoms. I'm going to choose to represent the iron atoms with a little red circle. Obviously yours can be different. And then you want to decide how you want to space those little iron atoms. Since the steel wool you were dealing with was a solid, we know that the particles in a solid are very organized, tightly packed. So I'm going to go ahead and do that for a section of the steel wool here. For time's sake, I'm not going to fill out the entire piece of steel wool, but you can get the idea what's going on there. Now, because steel is an alloy of iron and carbon, it's got a small percentage of carbon, and the carbon probably can be in different percentages depending what sort of steel you're dealing with. But I'm going to use black atoms to represent the carbon atoms. So I'm just going to put a few carbon atoms dispersed in here, and that's the main difference between the element iron and steel. And just those few little carbon atoms give steel its strength over just plain old iron. Now when you pulled the steel wool, you were separating the clump of steel wool into little strands, and one of the major misconceptions here is that you're pulling the atoms apart. But you really have to think about what the pulled steel wool, what phase it was in, and it was still in the solid phase. So even though you're pulling the microscopic strands of steel wool, or the really small strands of steel wool, you're really not pulling the atoms apart. So because the after picture is still a solid, we're going to want to draw those iron atoms and carbon atoms tightly packed, just like you would in a regular old solid. So again, I'll just do a portion of the after picture, and what you'll notice is the atoms in the beginning are still arranged in the same way. I wouldn't say that those carbon atoms and iron atoms are bonded, they're just really well mixed together into a homogeneous mixture. But because the arrangement of atoms, because the bonding or the lack of bonding is still the same, this would be classified as a physical change.